You recall that I talked a great deal about pattern integrity, and there is one episode in my life that I think really dramatizes the pattern integrity. In 1930, I was asked to speak at Dartmouth University, and I had my Dymax in-house at that time and model, and they had me speak in the Dartmouth Hall, which was a very old hall there, and all went well. Many years went by, and I was asked in 1947, 17 years later, to come back to Dartmouth to speak. And I spoke again in Dartmouth Hall, but in the meantime, there had been a great fire, and Dartmouth Hall had been burned up, and they were so fond of it, they built an exact replica. So I was introduced to the audience as having been there 17 years ago, and when I then began to speak, I said I didn't like to be contradictory, but I'd never been there before. Because I said Dartmouth Hall had burnt down, so we obviously went to the same building. And in the meantime, 17 years, all my cells had changed. There was nothing of the only thing that really had any identity were my eyeglasses, which hadn't changed. So here we had an artifact of one of the extracorporeal extensions of human beings that I spoke to you about, which was really more permanently part of the pattern of me than any of my flesh or bones. So that the audience really understood quite well what I was talking about in the pattern integrity. I'm going to talk now about what my strategy, my feeling as we go along now about how I carry on. And I've certainly, obviously, done my best to present to you a grand strategy of problem solving. I brought you into some mathematical thinking about that. And I've done my best to introduce large patterns, because we know why I've done that if we see enough pattern, we may have a chance to discover some of the repetitive, the periodic relationships that are occurring, and we can really witness fundamental change in the evolutionary relationship of human beings to the universe. But I have in my storage here several other large pattern considerations that I employ a great deal, and let's get those out of the way, and then I'm going to gradually come in much more tightly on the energetic geometry. We just touch a few items there, and I'm going to come in on what are called design science. I'll come in on our world game, and I'll come down to a great deal of where we are on our planet right now, what I see going on in all humanity, and particularly what I feel the little human individual can do, but each little human being is so aware of so many other human beings, and the planet being so big, and the complexity of things that are already operative when you check in the picture, and the automobiles are rushing by, whatever it may be, doesn't seem very good prospect to the individual. He's going to be able to be very effective in this great big pattern. He might expect to be fairly effective in a local pattern with a few people, but what you do, what the little individual human can do about humans on board of our planet in a big way, seems for the moment pretty formidable challenge. So I will talk more about that with you, because I'm confident the little individual can do a great deal, and every one of the human individuals are going to be able to do a great deal. And if you catch on to the strategies that I employ, you may be able to employ them too. You may want to. I've talked to, but tonight I'm going to clean up 2 or 3 items. One thing I've talked a great deal to you about is precession. And we mentioned it a number of times, and you now know what it is I refer to when I say precession. And I'm not going to talk much more about it, because I find that, at least it seemed to me very clearly in evidence long, long ago, that the gap between the humanities and the sciences I hope this all stays in the picture. The gap between the humanities and the sciences that C.P. Snow talks about in The Two Worlds, I feel is one that is spannable, and since C.P. Snow wrote his book, we have met and have talked with him a great deal about it, and he tells me he has changed his mind now. He does think it can be spanned. And I felt when I was young that there were so many things that I could see and feel very clearly, but I kept looking then for scientific concepts, principles, which I did not feel that I or other human beings tended to sense very clearly. And of all the big ones I came to, precession was by far seemed to me the least sense. You have the words, and I'm going to just go through some things of a child. The fundamental spontaneous participation of a child in the permitted degrees of freedom of our universe, and what I'm saying makes me think that I may start a little further away from the immediate demonstration of precession, and because I think these are so interconnected, these child experiences, that I'd rather start a little earlier in the child experience thinking. And as in the previous nights, I have told you I was going to do a little digression, but it will not forget where we are at all. I've thought a whole lot about what the relationship of the grown-up to the child, and relation to what everybody discussed a great deal, education. And I mentioned to you the other night, trying to identify as closely as I could what it was that I personally was conscious of doing when I say I'm thinking, recognizing there was a great deal of spontaneity of preoccupation, and subconscious things do occur that we find that our brain does seek for information when we ask it a question. And think about the relationship of the older people to children, and the idea that the child is not an empty container which the grown-ups then gradually insert their knowledge and their wisdom. That the child has incredibly high potential, the faculties that are there, the way they could really be used if they're not frustrated by circumstances, and circumstances could be animate or inanimate. And going to our friend pattern and integrity, I want you to think about a little child being born, as we've said time and again, absolutely helpless for months, can't even move itself around, naked, beautiful equipment, but no experience, therefore ignorant. So this had a little child, and the little child has been his mother so used to the idea of this little child is helpless that she moves around and she lays in the crib and so forth. And the child is lying on the bed, and as the months, time going on, the child is growing, and his feet are growing long, legs are getting longer, and his feet are weighing more, his hands are weighing more, and so forth. And there comes a day when the child is lying on the bed. Mother's left him there, and he's just moving his terminals, which he's been doing for a long time, and suddenly the child gets his leg up like this and an arm at the same time. He didn't realize it, and it overweights him, and he rolls over. And there's nobody around. Mom hasn't moved me. This is great. I didn't know I could do that. So the child, what was it I did? To keep doing this, and over it goes again. Very often children roll the edge of the bed and go off. And luckily they're designed hydraulically and pneumatically, as we've talked about, so they can take really quite a fall and a punch like that without, it distributes the load so beautifully, the hydraulics. It doesn't do any harm. But there's a great memory of something that happened as a consequence of moving around experimentally on your own. You get a little trouble here. Something hurt. So that we have a little child then crawling around on the floor, and then gradually climbing up and things. Because there's something around here that Mother isn't around here. There's something every time I try to do this, he's doing this to me. And this, a lot going on around here without Mom. This thing is around here all the time, keep moving everything this way. So finally, the little child does learn to stand up. So, but it's very, very conscious of this thing. So the little child is feeling that, and they're running around the house, and suddenly see the banisters. Now, I want to realize also in this little child doing this, also wants to get back up. He wants to climb up and things right away. He got a feeling of sort of working against this thing, goes that way. So he learns about getting up on the up onto things like that, and then coming off of it, he's learned that he. Wish I had them all around me. He's learned to. He's on the bed, and he can remember about, he wants to get off the bed. They laid him on the bed. So he wants to get off, and he learns he can angle himself up like this. Something to do about angles. When he got angles like this, I'll have to go further. So he can do that. But he angles up like that, and then pushes back a leg here. So he angles himself like this. Now his legs are out over the edge of the bed. And he remembers that it hurt very much when you let go. So he learns to angle like this, and every time he gets a little too far, he learns he can do this. And so he's changing his position. Finally, he lets go and goes here. Now, what he has been doing, this mysterious phenomenon that's around him, he doesn't have words for phenomenon, he doesn't have words mysterious, he just feels these things very powerfully. There's something here that when he does this way, he accelerates, and when he does this, it goes the brakes on. So he's got both an accelerator and a brake. It feels pretty bad, it's pretty dangerous. I want to get my legs as near as I can to the floor before I let go. So you keep putting on the brakes, and finally you're going to go. And so I've learned then there's an angle control. There's something about vertical and something about horizontal. He doesn't have the words, any such words. And the little child running around there sees the banisters in the house, and that angle looks kind of familiar to him. So that's sort of a critical angle, halfway between the accelerator and the brakes. And by the time he's been holding on to a lot of things, cramping, so he feels I can hold on to those banisters, and that angle there, I'll start sliding. So nobody's around me, climbs up, and sure enough, he can let go of those, hold on again, puts on the brakes, and he found a beautiful ride. So now there's something around him all the time, that, not mom and nothing, that gets him from here to there. So this child feels very strongly that coasting business, the angle of the acceleration he has. Suddenly there was a winter day, he'd never seen winter before, and out comes out of the front porch, and it's all snowy and ice in the city, and he sees that angle on the steps there. And he starts to go out, or walking out, and he never had ice or snow before, and didn't realize it's going to be slippery. He's used to floors that are not slippery. And he goes sliding down the first steps to the street. He said, boy, that's great. So I don't want to do, hurts my back. So he quickly finds something he can sit on and starts doing it. The children are fantastically inventive about and finding something they can coast on. Now this little child, the parents are always afraid that children are going to get themselves in trouble. And I'll just point out to you, this child is perfectly spontaneously full of the awareness when he let go. The further he is from the floor, the more it hurts. So there's something about height. There's also, if it's angular, if the angle feels right. He doesn't have any words yet, doesn't use the word angle, but he feels the angle absolutely, completely. You know, just as hunching himself up like that. It doesn't be more angular. Nothing more, as his hands have been doing all that time, his arms have been doing, he's angling. The angles are very, very familiar to him. And he has angular controls. So, what's he doing? He's grasping like that. It's angular control. So he feels very strongly the angle, and he understands that horizontal, because the street is horizontal. I say he doesn't use the word horizontal, but the street is horizontal, which means brakes. It's going to stop. Therefore you feel, as long as you can see at the bottom where it comes level, you'll perfectly well dare to go down the slide. Because you really felt there was some little friction, quite different from a free drop, as long as the right angle of feeling. So kids really judge this coasting thing very powerfully, without anybody telling what to do. So I now have this child that's learned, and I say, no child will go over a cliff. Parents say, I'm telling this guy, this child will go off the cliff or go off the house. They couldn't be more aware of the hurt there. They automatically do not get in trouble. They only do these things when they can see the horizontal. They see the brakes. Couldn't be more logical. I have this little child who's never been out of the city, and this little child comes into the Powell Indigo television, and they're having the ski trials for the Olympic ski trials in Hokkaido, Japan, and this little child is in Philadelphia, never been out of Philadelphia. And he sees there's quite a mountain there. Well, he's had a pile of pillows on his bed. He can understand a hill, the feeling of a hill fine. There's a big one. And he can see then that angle, and he feels that feels good to him, and he sees the snow, and that seems good to him. So everything that goes on there in the skiing looks absolutely logical to him. And what the skier is doing, he's got angle, he's angling his using angles on his ankles, and totally angling as he comes down. Everything's angled. Position's angled. The child feels it absolutely, completely logical to him. Now what I'm getting at, incidentally, I was asked to come and speak in Aspen, Colorado in the winter, and it was 1972. And the professional who started Aspen as a ski run after the Army used it for training. The professional they first had there to really turn it into a ski resort was Islin. And Islin was still there in 72. I don't know whether it still is. And Islin said to me, "Have you ever skied?" And I said, "No, I never did. I did radio skating, but I never did skiing. I guess I'm much too old." He said, "Not necessarily." He said, "If you'd like to, you have to get the right equipment to get you properly fitted out. If you like, I'll take you out and see how you do really get on." So we went at it for 2 or 3 days, and he said I could ski. And then I felt very obligated to this man. He was the professional. He was doing this all for nothing for me, and taking a tremendous amount of time. We were having hot tea and coffee after skiing, and I told him what I just told you, and I said that I'm not going to give you the scientific description of skiing. I'm going to give you the scientific generalization of skiing. It's called angular valving of gravity. He said, "I never thought of it. That's exactly right." Isn't that interesting, really? There is a pattern in integrity. We're getting really out of generalization. We find that, and that this great skier really felt that was absolutely accurate, and he enjoyed it tremendously. This then relates to what I feel about education. That is, I'm absolutely confident that the child and the human being must teach itself. It must really find out. It has to have confidence as it goes. It's got to get a feeling what it is all about. Then what the teacher can do is then, if the child has experienced a little of that, then the teacher can do what the television did. It can tell you that there's a great big mountain instead of just a little hill out in front of the house, and the same principle is going to work. So the teacher must really only amplify what it is what the child already feels, and feels very, very deeply. And to assume that the child didn't feel it because they didn't have the word gravity or horizontal is absolute nonsense. Those are very limited, special ethnic experiences, and the communication is already, the lines are open, and whatever words have to be used are fine, and the child will take on the words as long as it's identifying what it feels. Now, this brings me back then, as I said, to precession, thinking about precession. I have a little child, and the little child then we found learned it could roll over. That was a whole lot. It was something, not the original experience at all. So then the little child, when it does finally stand up, having actually rotated, then the little child very quickly finds children trying this. They have a lot of fun spinning around, spinning around. So then, that is one of the prime motions of our universe. We have our axial rotation of our planet. We have the axial is very, very fundamental to the universe. Then we have the same little child learning that not only that, but he can also go into orbit, go around circles. Then he finds that he can go into orbit while axially rotating too. So we call that dancing. So we've got two very important motions of the universe here. Then the little child learns that it can take in its breath, it can expand and contract. Very fundamental motion of the universe. We've got three very important ones here. Now another one he can do is to twist his top one way and his bottom the other way. We call that twist in dancing now, but it's torque. So torque, we have axial, orbital, expansion, contraction, torque, four of them. Now another one is very fundamental. You just start kissing. Start to turn yourself inside out. I gave you the rubber glove the other day. Evoluting. With a rubber donut, remember, evoluted at the top and involuted at the bottom. So a child starts finding that involuting, evoluting, which is the pattern you get in all of electromagnetics and so forth. So there are five most fundamental motions in the universe which the child is spontaneously familiar with, and you can talk about. But the word precession, we come to that, and the child's kind of blank, and the first child experience of precession that he might be able to catch on to is when his uncle brings him a top. And the uncle brings a top and has quite a time winding it up, and then after a while gets the top going. So the top is actually rotating very rapidly, but also so it has a secondary very slow motion. It's leaning way over like this. And the little child has learned when he leans way over like that, he keeps on going. So he said, Uncle, why doesn't it fall over as it's leaning? So Uncle said, I got to get a cigar, and that's the end of that. The reason, of course, is precession. And the reason he was familiar with these other 5 is that he seemed to do them all alone. One of the things that engineering tried to remind the non-engineer about is that every action has a reaction. But to a little child, the fact that he is doing this doesn't make him realize he's pushing the earth that way, though. He's so tiny, the earth is so big, there's no such awareness. But of course, he is affecting that planet, and incredibly meager degree, but is doing so. Now, precession, I said, was the effect of bodies in motion on other bodies in motion. So he really was doing a precessional thing to the earth, but he's unaware of doing it. So the first 5 are familiar because they seem to be within yourself. And you do not think of the earth as in motion, even, let alone that you could push it a little. I can understand that why precession has been so, in a sense, remote from the basic thinking of the individual feeling himself very independent on what seemed to be a flat earth going to infinity. And he's the only thing in motion. Now, precession, I was the science and technology advisor on the staff of Fortune magazine for 2 years. They had no editorial titles on Fortune, so that they did not put that on the articles when I wrote. But my job was to, when Fortune was taking one big corporation after another and explaining the great, enormous work that corporation was doing, and explaining which executives had the highest initiative and so forth, they did very good stories on these corporations. But the managing editor who brought me on to Fortune, and Henry Luce at that time, in 1938, wanted me to try to bring home to the readers of Fortune a little more insight into the science technology that really lay behind that great corporation's activity. And each one of I was only put on stories where the technology was something difficult, and when I came to do those stories, the chief scientist, the vice president in charge of research and engineering, whatever it might be, would always say to me, it's going to be impossible for you to tell the Fortune readers what it is we are concerned with in depth in science here in our company, because it can only be expressed mathematically. And the Fortune readers don't read the mathematics, and very few of them do, therefore there's no way you can talk to them. And I'd been given a double spread for each of my stories to tell. And every instance I was able to tell the Fortune reader what it was that I engaged in depth without recourse to just mathematical formulas. I was able to bring it into some sensibility that I just gave you, the same kind of sensing, identification of experience of your own body. And so we came to doing the Sperry Gyroscope Company in 1940. World War II was looming. Sperry not only had the gyroscope, but they a Norden bomb sight, and it was a Norden bomb sight, and it was a very critical, from a national defense policy, it was a critical area, and yet they did not feel it would be in any way putting that operation into jeopardy to have me talk something about the technology. Anyway, the very essence of the Sperry Gyroscope Company was a gyroscope. And the gyroscope does what it does as pure precession, which is employed. They said, just to show you how impossible your task is with double spread, we have to have a primer for the Naval Academy midshipmen, because the Navy uses so many gyroscopes for so many controls that the naval officer has to have some important insights into what he's dealing with. Therefore, we have this primer, and it takes 50 pages to tell the Naval Academy midshipmen about precession in an important way, and it's entirely quantum mechanics. So that they said, your task is impossible. Now, I did, and I had only 30 days to work on this story, and I did come out with the explanation of the precession and the gyroscope, which I brought it to your own senses and did clarify, and the scientists of the Sperry Company said they really were astonished, but they agreed that it was not just a sort of happy analogy I was using, it was absolutely the direct explanation. And they had not realized it could be expressed in terms of senses, because it seemed to be a very perverse matter. Precession seemed to be a very perverse thing, like a kid saying, why doesn't the top fall over? Now, there are several matters that are going on in the precession where we're dealing in accelerations, and there are two kinds of accelerations that are recognized by the physicists. They're what they call linear and angular. Linear are obviously like that. Or angular, just think about then swinging the weight around your head, the hammer thrower. It is angular acceleration while you're having some restraint on it, and you're making it work in a circle, and you let go of it, and then it goes linear. Radial versus circumferential. Now, the precession one I spoke to you about is that, and we're going to try to have some sense of understanding why it is, because I'm sure that most people then, the feel is that gravity is 180 degrees. The Earth, for instance, ought to fall into the sun, and why there's an effect of the sun on the Earth make it go in orbit around it at 90 degrees instead of falling in. This is one reason why it seems perverse, because the child really thinks about that gravity pulling this way. It's very 180 degree fair, and it's just, human beings get to be very linear this way. They want to explain things very linearly. They look in this direction. So now I'm going to go into some explanation. I'm going to think about an athlete we call a hammer thrower, and we have the heavy weight ball, metal ball, and a rod and two triangular handles for this professional hammer throwing. And he is lying on the ground. He gets into acceleration, and as he gets into acceleration, he gets it out horizontal. And then here we get into something quite important, because he can actually build energy or momentum into the system as he gets accelerating this weight. And it gets going fast, and it's really using his muscles to get enormous acceleration. Otherwise, you can accumulate energy in this angular acceleration, and so when he does let go of it, then it goes off in a line. With that angular acceleration, how far he throws it, how much energy really got built into the system. I'm going to have a special apparatus for we're going to have a great Olympic hammer thrower, and we have a wide belt made from a very powerful belt, and it has many hooks on it, powerful hooks. And we get him start one of these accelerations. He gets his ball accelerating, and we get him to hook it onto his belt, and we give him another one. He gets that going too, along with it. That's probably be in the opposite direction because just balancing the weight very spontaneously. He gets that hooked onto his belt too. Now he's built up quite a motion. He can't really stop very much. So we hand him another one. We keep giving him one of these and get one by one. We get them accelerated and hooks them onto his belt. Till finally he has really a whole grass skirt horizontally out here of all these balls, and there's so much momentum built into it that he cannot really stop himself. And he would be in a lot of trouble. So we've anticipated by the floor that he was on, we had already made a turntable, very nice turntable, ball-bearing turntable, but we'd had it locked so he could get it, shove off and get his acceleration. But now we release the table so it can spin all right for him. And we also then make him really comfortable. We bring down a ball-bearing pad on his head with his arm from above. And so he's between the floor and it's moving around very easily. So the balls can just build all that momentum. So he's spinning around it. The balls, he gave so many, they're touching one another. But now then, I'm going to leave him spinning for a minute. In fact, we're going to another man who's not really an Olympic game. He has a mouthful of plastic peas, and he's got a tube, aluminum tube, plastic, and he's a pea shooter, and he's blowing peas out the end of the tube. And we could use other things. A machine gun would hurt you if you put your finger in the way. We could use a hose of water, but you can't see the individual molecules. But pea shooter is very convenient because you can see the individual peas coming out. And if it blows good and hard, they go out fairly fast. So you find that with the peas coming out, you can come over and put your finger in the trajectory of the peas. And if you put your finger and coming from the side like that, you make it deflect over there, can't you? Or you put a little bit under it and make it pop up a little. You can change it angularly. I found that. This is our angular valving. So we can change the trajectory. Now the fact is that no matter how hard he blows, it only goes away before gravity pulls it to the earth. And so the gravity blowing, if you don't put your finger there deflecting, there's no wind. As it blows it, the pea goes operates in a plane, and the plane is perpendicular to the earth as gravity pulls it in it. So you could really describe this as a curve on a plane. So what happens when you put your finger there to move on one side of the trajectory of the peas? You simply make it change like that, and gravity still takes over. What you really do is push up the plane in which the pea is operating. You push it a little this way, right? Feel that? So I put my finger. Then if I remove my finger, the pea doesn't act as if there's an elastic band and try to go back to where it had been at all. It's simply, it's been changed its angle, and gravity is also changing. It's got two forces operating on the pea. Three forces: the original acceleration, then my deflection, and the gravitational deflection. There are two angular deflections operating on it. But the point is that it does not then have memory and try to go back to what it was doing before. You understand that clearly? The pea simply, if I push my finger, the next pea will then go over here. So it has each pea has, however, then a plane which it moves in. If we put a permanent finger here into the trajectory and left it there, all the peas will follow the same plane. You didn't push it any further. The plane could be reoriented, but the point is, the minute you stop pushing it, it holds that plane. It does not try to come back to where it was before. Now, I'm going to now we've learned individual peas can be deflected. And we can push one a little further than the other, but the individual can be, and once you're given this new angle, it's going to keep right on, and it's now only being affected by the gravity. Gravity is the other one that's altering it, the only one. Now I'm going to come back to this. Now that we've learned what happens in individual pellet, I recognize then this hammer thrower going around here. These are individual pellets that he has out there. They're individual energy units, and they're very much heavier than the pea, but they follow the same laws exactly. If it had cannonballs coming out and had some kind of a steel finger you could put in the way, you could make the same deflection. Now, I'm going to point out that the ball-bearing turntable we had underneath the hammer thrower and the ball-bearing pad on his head, each one of them were mounted on arms, a vertical arm going that way and a vertical arm going that way. And they were mounted from an annular ring, great big annular ring. And the annular ring would go 90 degrees around on it from this pivotal point, and we got another set of hinges, of trunnions. We built what we call, and then that's mounted in another ring. Get what we call gimbals. If you've seen gimbals for a gyroscope, it has now all X, Y, Z axi of rotatability. So this man is spinning, and he's in gimbals. Now, I'm going to have him spinning out here in front of me, so that you can see. Maybe I'll do it. I'll have him spinning over here, and I'm going to come over as those individual pellets go by, hammers. If I put my finger down in here, maybe I put something guard on it so it won't hurt too much. If I put my finger down and touch one of those balls, I'm going to deflect it. Agree? So I keep my finger there, and the next one, so once I've deflected it, it doesn't have any memory, want to come back, so as the balls are going around, this one I touch it, and it goes down like that. But it had another restraint, which was the rod pulling it, which was just as the pea had gravity pulling it, its own acceleration has been, gravity was no longer affecting it. You can do that. But the point is that the rod was really tantamount to the gravity that pulled on the pea. So after I touch it, the rod is still holding on to it. So this pellet went by me here, I touch it, it goes down like that. But it's on the rod, so it's going to go around in a circle. So I keep my finger there and touch each of these pellets as they go by, and each of them peels off. I've had a nice mathematical control for my fingers, so I would just give it exactly the same touching. And each one of them peels off like that, one after the other, very much like airplanes coming along in a flight and they suddenly peel off to go down. So all of them one after the other. We get into then a new plane. The wheel which had been revolving horizontally here, you can see the man's in front of me here, and I've just touched it at this point. So each one of those pellets goes slanting down like that. From where I touched it, it slants like that, but then it stays in and goes around, it comes up on the other side. So as each one, for the moment it's really terrific bending of this thing, because it's been a very severe angle as you touch it, but it goes on. In fact, I keep my finger there, it's all gone by, and the whole thing's changed. It means then that the plane that I had been dealing in, I wish I had a little larger disc. Could you let me have your book? So I touched the pellet here, and one by one, and they slant like that, because I did that. Can you see that? My deflection was this way as it went by, so this does this. But it was restrained, so it stayed, the whole disc then does this. Which means then that the axle of that wheel also then has to stay perpendicular, because we had him this very wide belt, and he just normally has to do this. So the whole gimbal permitted it. There were hinges on the annular ring here, the horizontal annular ring, so the whole thing is able to hinge that way. So when I touch it here, the whole disc changes like that. But the axle just goes up. You see that? It feels absolutely normal to what I told you, doesn't it? Nothing wrong with that. That's exactly what these wheels do. So now, I had a hammer thrower, but instead of Now, I'm going to talk a little more. When you do touch a gyrating wheel, rotating wheel like that, there's enormous strain in it because you're really touching at individual parts, and they're trying to really break the wheel in two. However, if before I had touched one of those pellets, I had, as they went around, I had draped very powerful Scotch tape on top of it, glass Scotch tape, and it went all the way around. We would have a condition where these balls are touching each other, and there's a tension tape on top of them. Therefore, if I touch this ball here with the blue one on top, it's going to do this. It's against here, and there's tension across, so that it's simply going to pull like this. And this acts as a fulcrum, and it lifts on the one behind this. The third ball behind, as this one goes down, is going to lift the one behind it. As tension in the system, on top of the system, if I touch this here, it'll work back all through the whole wheel, so it helps the whole wheel to tip a little faster, because not only is the one I'm touching going down, but the one behind gets lifted. But all around the same axis as they're going around here, the axis between you and me, because I'm touching it here, and it's going in that plane. Now, then I point out that instead of putting the tape on the balls, I'm going to give the hammer thrower twice as many more balls and have him spin it and get him loaded up. Now you find that the first set, the acceleration was such that they were out horizontally in respect to his waist, and I've given him twice as many, so he gets a layer on top and a layer on bottom, and they are trying to go horizontal, so they press together on the ones that are already there. They'll nest in the valleys of them and grip them very tightly. If I gave them more layers, they all try to get into the horizontal plane, so they grip it even tighter. So it begins to act as a unit material and has the same tension effects as that tape I gave you. So this is then I was more or less describing really what a flywheel looks like that you have in your gyroscope. But we understand the very center of that wheel has this in its individual atoms, and really must be thought of as individual quanta doing just what I said. I've shown you how the quanta do the friction and the intertensioning of this. The friction of the one ball on top of the other would make it do it. We have the mass intertraction of the balls too. So you now understand that instead of thinking about the man as a man, I want you to think about it as a steel axle perpendicular to the wheel. So I'll simply tell you, if a gyroscopic wheel is moving in gimbals in front of me high speed, if I touch it, you've probably heard of the finger. If you take any tiny little metal finger, just touch it here, the whole wheel does just what I said. It's going around this way. I touch it right here, and it rotates this way. Let me show you understand it. In front of me here, and there's an axis between you and I, and it rotates on that axis. Now, instead of touching the wheel, if it were made out of steel, there's a steel axle. Supposing then, instead of my pushing down on the wheel here, I leaned in over the thing and took hold of the top of the axle, or took hold of the top of the gimbals where the gyroscope is mounted, and I pull the top towards me. It would be the same as if I pushed down here, wouldn't it? So rotating this in this plane. I'm forced in this plane between you and I and the circle there. So if I took hold of the top, pulled it towards me, then I would get exactly the same results if I pushed down here. So you do try that with the gyroscope. So you pull on here, and it doesn't yield to you. It goes over to your right. Now suddenly I want to realize I've brought you clearly through so you understand. People say that's very perverse. I push on the top of the gyroscope thing here. Instead of it's yielding to me, my pushing, it goes at right or left. It goes into the plane at 90 degrees. This is why precession has been considered so difficult to understand, because human beings think it ought to go. If I push on it, it ought to yield the way I'm pushing it. And the fact is then if I push on it, it goes to the right. If I push on it harder, it goes faster. And it keeps going to the right as fast. So if I keep pushing on it, the whole thing just keeps going around in a circle this way. The whole thing, the axle will be going around a circle at a not the direction I'm pulling, but in a plane perpendicular to me. If the wheel had originally been going the other way, it'll go that way. So long as I push it, it keeps on. If I push it harder, it goes faster. The minute I stop, everything stops. It doesn't have a memory to try to be something else at all. You can understand that, right? Now, this is the gyroscope. And I hope I've really introduced to you why you felt the way through. Now, if I didn't bring in the paradox of the way you feel until the end, so that you really could feel it with me all the way, and everything went on, it was absolutely normal. It's exactly what your experience tells you will happen. So I find that the error has been in humanity really thinking 180 degrees. And you say, anybody can throw a straight ball. Now what really goes on when you throw the straight ball? The pitcher may get a part of a circle and wind up like this. He just sends him out. And he goes over like this. Now the fact is, the pitcher, you're looking that way, and you've been throwing balls for an awful long time. You say, I'm throwing that way, therefore I throw it there. You don't. He lets go here at 90 degrees from the direction he wants to go, and then goes in that direction. He may go on with his finger to put spin on it, which he does. And he doesn't try to stop himself right away, but the point is that his acceleration is this the way you let go, and goes at 90. I want you to make that a little clearer. You're playing tennis, you're serving. You throw the ball up here, and you hit it at 90 degrees, it goes over there. We've always been operating at 90, and we've absolutely kidding ourselves into thinking that we're throwing the ball out here. We don't throw it out here at all. If we throw it out here, it goes in the ground. Now, this is good fun to catch ourselves in ways in which we've been able really to deceive ourselves into what it is we're really doing. The precession couldn't be more normal. What's abnormal is that we've kidded ourselves into thinking you get 180 degrees. The trouble was the shooting of a gun, that fooled you. It's another kind of acceleration. But you tensed your bow, the bow is vertically, and you tensed it this way, and it went that way. And just come back to when I remember with the rope, I took a piece of rope, and I pulled on the rope. The moment I pulled on it, the tauter it became, which meant that while I'm pulling it this way, it's going into compression at 90 degrees of my pulling. Remember that? The other day when I loaded in compression with all these rods, already in closest packing, they couldn't go towards each other. So as I loaded them, they all began to cigar. And the binding that I had around went into was offset by this pressure. So my compressioning got at 90 degrees of tension, and the tension got 90 degrees compression at 90 degrees, and I gave you the electromagnet and it poached the copper coil. No electric current at all, but just electromagnet poaching it, and it induces a current, and the current goes at 90 degrees to the, and the sets up a field that says at 90 degrees, don't come any further to the magnet. I stop moving the magnet, everything stops. Precession stops. I start pulling the magnet the other way, as the copper wire becomes another current again, and it sets up a field, tries to pull down and says, don't go away. The precession counter, it's completely regenerative. One brings out the other. So I gave you the other, dropping the stone in the water, and the wave went out that way. And this way beget that way. And that way beget that way. And that's why your circular wave emanates. Once you begin to get into precession, it gets to be, you find yourself understanding phenomena that you've seen those stones falling in the water for all your life, never really knowing just why the wave does what it does. Well, I'm now quite confident that I've taken you into precession and given you a very, actually hooked up your own senses with it. There was another phenomenon in there that's very important, which is acceleration as also orbitable, the precessional effect of the moon, of the Earth on the sun, the sun on the Earth, making us go into orbit around the sun. And then we are doing the same to that moon. And I find then it's an amazing matter that Professor Goddard was not understood, and it's an amazing matter how really beautiful was Goddard's accrediting what Isaac Newton had discovered, which I also went over with you the other day. Every time you halve the distance between the two masses, you increase their interattractiveness fourfold. If you double the distance away, you decrease the interattractiveness to 1/4 what it had been. And nobody really paid attention to these kind of things in a personal way, in terms of their senses. Professor Goddard did. So he said, our Earth is already going around the sun at 60,000 miles an hour. And if we gave some object an acceleration, because any object on board this planet is going also at 60,000 miles an hour. So this happens to be going around the sun at 60,000 miles an hour, just in company with the Earth. So if we give any object an additional acceleration over that 60,000 to make it then begin to leave the planet, then every time it gets to, every time it doubles this distance out, it's going to reduce the tendency to fall back in to 1/4 what it was. You will not have to go very far out before you don't tend to fall in anymore. In its own independent acceleration, its own orbiting. So this is Goddard, and it's a very simple matter. I find human beings again on board of our planet not tending to, we're so tiny and the total experience is so big, not tending to really get things into scale. But when we accelerate, and we were first told that the rocketed vehicles have gone into orbit, we thought of them as very far out, because our highest mountain, 5 miles above. When we get to our airplanes, many of them are flying at the jets at 40,000, 30,000, 40,000, and well above Mount Everest kind of thing. We get to 50,000 and you're, what are you? That's only 10 miles out. So we get, and at 50,000 you can't see the plane. So that's only 10 miles out and you can't see it. So make 10 times that, or 100 miles, and just assume that's fantastically far out in the blue, the way it looks to you and I on our planet. But the fact is that our vehicles began to go into orbit at 100 miles out. Now the diameter of our Earth, 8,000 miles, and 100 miles in relation to 8,000 is a very small amount, isn't it? If I then take a thin paper match and glue it onto this globe here, that is 100 miles out from the surface of this globe. Otherwise, it would look to you exactly still in the globe still, but now it's independent, it's in orbit. In other words, you don't have to go very far out in this universe before you get beyond what we call this critical proximity. You no longer tend to fall in. Falling in is a very, very rare part of our universe. Very seldom does anything get close enough to fall into anything else. The norm is orbit. And this 180-degree falling is something called critical proximity, when it really becomes part of this mass. Now, and when you get yourself feeling a new norm here of the normal normality of precession is also, then I talked to you the other day about man and all the other creatures on board of our planet, and we went into how and why we're here. And I identified man as having a function in the universe, and that he, in order to get him ready for it, he had to go through being born naked and absolutely ignorant, having to make trial and error to get somewhere, to learn generalized principles, where he could really then employ the principles to, as no other creature could, to make it possible for him to deal in larger and larger parts of the universe, and get environments he'd never been in before, and get on appropriately to get more and more information, which is his function to process and to solve problems. So we had then all the biological life here to support and make possible that activity. We found that the mammals couldn't take any of the sun radiation through the skin to keep the energizing, re-energizing, which we all have to have, so that we remember then, I gave you the pattern of the trees being rooted in order to be able to do what they're doing, how they're getting the water and not to blow away. And then we found that because the vegetation was rooted, it couldn't procreate with other vegetation there. All the insects and many, many mobile creatures designed to traffic back and forth between all the vegetations to cross-pollinize them, so the whole system regenerates. So I have then the big thing is what we call the ecology, and is an orbital affair. It is a cyclic affair, this way, and not this. But in order to get creatures to do these things, they give them chromosomic construction. They're designed structurally, mechanically, beautifully, and given the chromosomic drive to go after the honey. I had then man going after his honey, called money honey, so something he could exchange for goods, because he then inadvertently having had his hunger, but also having a procreative urge, he's inadvertently made children, because side effects, and it increases responsibility, so keeps going after this money honey more to try to take care of the side effects. And inadvertently begins then to do the things it's supposed to do. So I gave you then man with enormous fixation on the 180 degrees, but the precession and the orbiting is the normal. And that's what ecology is. This eternal regenerative universe in all the ecology on our planet, and to support the human and human mind's activity to really deal in principles of universe and to solve local problems in pure principles is a very important function. So I hope I've now brought you back to really feeling the normality of the ecology and the normality of all the orbiting, and whether it's the orbiting of the electron around the nucleus. Orbit. This is the normal of the universe. All the inner effects of all bodies in motion and all other bodies in motion in the universe is all precessional. So I hope that instead of this being a word that seems remote to you now, it suddenly begins to be important. But it was also involved then in the picture I gave you of the hammer throw accelerating, that it wasn't horizontal. That is simply, again, if you accelerate an object on our planet enough, it tends to be independent. That's why a bicycle lying down on the ground is falling over. It yields to gravity. But you get on it, and the minute you start going along, the faster you go, the more vertical and stiffer you are, because if you get enough acceleration, you're going to leave the Earth. That's all you need. In other words, you tend to be leaving the Earth. So I said the acceleration been given to those balls by the hammer thrower was such that gravity no longer was important. They were really tending to be free in the universe. So I hope I've made clear all the items that need to be cleared to make precession seem to you normal. And remember yesterday when I gave you this, suddenly the octahedron, and just precessed the effect on that the octahedron, one pull effect, but precessed that one vector, and it turned like that and went from 4-ness to 3-ness, and went from being generalized case to specialized case. And really probably every time we go into all the special, we're going to nature reserves with one increment, so forth. So this is how we have the invisible, where all the special cases are all finite and discontinuous. You see how they can be. Now, I'm going to go into another area. And we haven't been going on long enough for a break now. So that I talked to you about my maps the other night, and I will not as yet go into how these maps are designed. We'll do that as we get into the synergetic geometries and so forth. But I do want to come back to man on our planet. I had given you the exercise of thinking about little man on an 8,000-mile globe, and that we are only the highest mountains, remember, were not the deepest oceans. That aberration could not be seen on a global globe like this. So the actual fact is the ink with which we print the water on this globe is deeper than the water by a good deal. And so little you and I would be very invisible on such a phenomenon. Yet little you and I, in physical stature, having this mental capability that we looked into to be able to take the inventory of all the chemical elements present in the 11.5 billion light years sweep out of the heavens, being able to develop the equipment to get into the invisible world of getting, and being able to photograph the stars and so forth, 99.9% of which are not visible to our naked eye. That human beings are able to, that you tiny little you and I are really able to deal with these magnificent scale affairs and to get the kind of information we're having. Now coming then to the development of human beings on board of our planet, which I went into a little with you the other day, I would like to go through going from that concept of the being born naked and have to be a place where you would not be eaten up and not freeze to death, and the coral atolls of the South Pacific being the most favorable possible place where you could be born and where there'd be no big animals to eat you up and so forth. I personally have been, this is highly speculative what I'm going to talk to you now about, but I was in the regular United States Navy at the time of World War I, and I became tremendously interested in the possibility of what I call a sea archaeology versus a dry land archaeology. So all the archaeologists were digging in and uncovering old cities and so forth, and putting together pieces. What it struck me very, very powerfully, because I was a sailor, was the relative ignorance in the building of the land. We just piled stone on stone, in contradistinction to what you really had to know about to be able to really build a successful boat, going from just a raft or a canoe, an outrigger, to big, deep rib, big ships carrying incredible cargoes around our planet. And realizing, I'll just give you we went through the other day tensile strengths of mortar, you remember, and stone being 50,000 pounds of compression, only 50 in tensile, and then we got into the metals that had high tensile capability. Historically, in building, man then gravity just helped him. We could roll the stone over and get it to nest on top of other stones some kind of way, chip it so you get it lay there. Gravity held the whole thing together. And the stone was approximately relatively imperishable, so they seemed to last a long time. And the great walls that were built by human beings that way would crumble down when earthquakes came, but otherwise they were pretty secure till an enemy might storm it and try to be able to knock down your wall. But the wall, this is the way things are built on the land. And the bigger and heavier and higher, the more secure people felt. And so we see all those castles, this kind of building. You could finally learn to have a stone corbel out, come a little way, and you can get it out, so you get some fairly interesting designs after you're deeply familiar with it. But you still have to play with gravity. It's a sort of a game. Sure, don't tip too far out this way. There's a stone in here. So human beings then dealing in almost completely compression and very poor tension capability. However, I want you to think about what a beam is. My hand is going to be a beam. My two arms are worlds. I got a beam between the two walls. I'm going to have a load on top here. As the load comes on top, the bottom tries to open up. As it tries to go like that way, the top goes into compression and the bottom goes into tension. And if the tension is not great, it just comes apart. So the whole thing comes down very quickly. Can you see that all right? The tension opening up. So when the Greeks then wanted to do some spanning, they had to get the columns very close to each other, and then they could get a very deep block of stone because you have your principle of leverage. The top is the fulcrum, and the deeper the stone is, the longer your lever arm, so that you know the further longer lever your arm, the less effort, so that the stone is deep enough. The tension can hold it together. As it gets shoulder and shoulder, the tension necessary to offset this has to be greater and greater. Can you feel that, all right? This is a lever here. So the deeper it is, the less effort to hold it together. So the Greeks used a very, very deep stone, and they only could span a very short distance between those columns. Come and look at the Parthenon, and you'll see those stones that are up there are cracking too on the bottom. You can see where they're trying to come apart. So we see go to a very ancient, like Mycenae, and you got a very small gate and a very deep stone. When they wanted to have any greater spans, they had to go to wood. So we find in all the antiquities all these verticals, because the verticals are where gravity is holding it together. Once you go horizontal, gravity's trying to break it apart. So beautiful gravity holding together vertically. This way, she works against it. Our old friend, angular valving of gravity here. So we have the human beings then using wood, because wood encounters, the masonry has said only 50 pounds a square inch, and wood you could get up to 10. If you get really very fancy woods, they get up to, in birch, very special swatches of birch, you might get up to 25,000. But wood, the tensile strengths of wood would be 5, 7, 10. 10,000 is very strong wood in tensile strength. But 10,000, as it gets 50, is very high. So, but wood is perishable, rotted and burnt and so forth. So that in antiquity we have all the verticals where gravity is holding together the stone, and the horizontals have gone, because if they're any span at all, because they were wood and rotted out. However, I want you to, and so I said, if an earthquake came along, the whole thing went down. There is really no important brilliance here, really. If a very powerful general and he had enough slaves and captives, so well, simply keep piling on the stone. There might be some artistic character around, so you'd like to have him chip the stone a little fancy for you. Or you'd like to have the general wants his name written in the stone there, or some picture of him. So there are people that had to do some superficial decorating, but engineering-wise, it was just a matter of pure muscle. Not mind at all. But this business of tension begins to introduce something to you, and the principle of leverage we talked about, that's a generalized principle, and has very important, discrete usability. So we come to a ship of the sea. People found then, I spoke yesterday about the 3/4 of the earth being covered with water, 10% dry, 25% dry land, but only about half of that was not rocks and deserts and ice, and getting down to around 1% that was immediately propitious to support human life. Where the things were growing, there were grapes to be eaten, there were bananas, whatever it is, and people could get going. And the people continually find themselves where nature went against it. There was a drought and things that didn't grow that year, so they were suddenly in mortal peril. And we went into the development of the city-state, or these walls, stone walls, and what the people who did find a very favorable place did was, like Mycenae and the beautiful Algolian plains there, they had found a hill in the middle of the valley, quite high, that had a well, and they built a great stone wall up there. and then they put stone grain bins. And when they saw the enemy coming through the passes, they took all the food and put it inside, and they scorched the field, so the people came outside, and they were very hungry already. You only go 30 days without food, approximately, so just watch the people outside wilt away. We have then other people who found the water had fish, and you could live on that. But the water might look very beautiful down at the harbor there one day, and suddenly go out there in the sea and an enormous storm comes. So the people found they really couldn't go on off on the three-quarters of the earth, which is water, in any important degree, till they began to have better and better boats, because once you think about a boat, and it's got a big wave, and the boat is then a beam between these two waves. You see that, right? So the boat is then being a beam. My arms are the peaks of two waves, and my boat is between us here, so that it's trying to do this. A minute later, the wave is in the middle of the boat, and then wants to go that way. So it's being racked this way and that way. Fantastic stresses, incredible stresses. Now, the difference between going to sea and being on the land is just incredible. Number one, I gave you, remember, crystallines, liquids, and gases. And the crystallines have a triple bonded, 3 times, a lot of tension to hold them together there. That the liquids were hinged, so they distributed loads, and the gases were universally jointed, so they distributed loads, but were compressible, and the liquids are non-compressible. When we then get the amount of energy necessary to disturb the crystalline in the universe, it takes 3 times as much to disturb the crystalline as it does to disturb the gaseous. And only twice as much takes twice as much to disturb the liquid as it does to move the gases. In the universe, one of the most interesting part of the great patterns of energy is I gave you yesterday the degrees of freedom, the way energies can get within any given move. You have when your turn to play, you get 6 positive, 6 negative moves you can make, and you could get way out. And I showed you how we got distance differentials entering into the total experience. And so we have energies dispersed and expanding universe. We've been into our syntropy and entropy and so forth. I'd like then to come to the thinking of fundamental experience, which is in relation to wave and frequency. The big ones, fundamental to energy in quantum mechanics, you start with the universe has a given amount of energy, and you can invest that energy into a lot of little things or a few big things. You're going to be able to get it back again and reinvest it, but generally the universe has the big things then cannot happen as often. So the novae are really very infrequent. Novae are very infrequent. Earthquakes are not so very frequent. Mosquitoes are very high frequency. The smaller, the more frequent the way of energy behaviors. So that the earthquakes occur on the land. Rarely do you have enough energy motion on the earth to break the triple bond. But very frequently we have enough energies to disturb the water, only double bond. And even more frequently we have enough energy to disturb the air. So we find that the waves in the crystalline, the earthquake wave is just really a little tremor, a very small wave. But our waves in the water can get up as much as 10-story building height. And the waves in the air get up to mile high. So it takes relatively little energy to make enormous disturbances in the atmosphere, and relatively small to make disturbance in the liquid, but very rarely to have enough to have earthquake. Seaquake every day almost, and airquake all the time. The interface between the liquid and the gaseous and is one with very high frequency untoward enormous stresses are operative. And so you just cannot go out with a ship in the sea unless you really develop a capability, an engineering capability, dealing in principles in every kind of way, really understanding of tension and compression in an extraordinary way, understanding hydraulics and pneumatics, very fundamental ways. Okay. On the land, as you do, you can have a job, and so you work for 8 hours and then call it a day. You can close all the shutters on the cottage and say that's the end of it. At sea, you can't shut down. This is a 24-hour job. She just simply continually comes to magnitudes of forced interaction with you and your ship. You just got to be on the job. So, and then live 24 hours, and on say if he had a long day and maybe had 12-hour day in the land, he at least had twice as much experience at sea, because you get 24 hours out of every day of experience instead of 12. So the experience piled up very, very rapidly, and the severity of the untoward events, very high frequency. Therefore, those people who did come back are very aware of so many who didn't come back, and they went into anticipation. This is our friend, comprehensive anticipatory design science. What are all the things you're going to have to anticipate? Furthermore, your ship, you had to carry, going to get any real distance, carry lots of foods, and it brings you into all kinds of problems supplying that crew. So we find the ship going very rapidly, differentiating into pure tension and pure compression, getting into what does make flexible cables. We've been into a lot of that. I've been into necklaces and structures with you, so that you understand what I'm saying here. But the ship really very quickly accelerated man's familiarity with differentiated tension, compressioning, angular controls, leverage advantages, whatever it may be. And you find the earliest known picture of a ship is one on the quays of one of the priests in Egypt. And that first ship, if you are an engineer, you recognize she's a good-sized ship. Her complexity technologically with several masts, the tensionings and the compressionings and the triangulations that are in it are just phenomenal. At that time, the tools that were pictured on the walls of that Egyptian priest were very, very advanced tools for making the ship. In contradistinction to anything being used on land at that time, a wooden plow. The tools of the land were just childish and compared to the tools of that sea. That ship, quite clearly, if anybody gets into such matters, the evolution rate of which technology does improve, we realize that that ship had been in development for 50,000 years. She's a fantastic, mature affair. I'm not saying that ship was built, but the information went in there that was actually coped with and employed in principle to make that ship a success was of thousands of years accumulation. Now, number one, on the land, so you get the sea quake. If a flood comes along, you're completely licked. On the sea, it's a flood all the time. So you're designed for a flood, you better stay on top of it. And your castle won't stay on top of it. So you can't have that stone kind of thing out there in the sea. Gradually, I became, as more I studied these matters, the more I became aware that the science and engineering of building of ships of the sea and then later of the sky were thousands of years ahead of the art of just building on the land, anything that weight and strong, that sort of didn't tip over, gravity holding together. So even as I grew up, we have the insurance companies saying, you know, strong as the rock of Gibraltar. The idea was just inertia. And we don't get over that idea of the inertia, and society is yet not over it till the last great walls with those of the Maginot Line, and suddenly, boom, World War II is all over. Why? What happened was that World War I, the submarine coming along, the tank and the submarine were coming out of the sea. Their technology of the sea. And they simply climbed up this time. You couldn't carry any great cargoes on the land at all. The railroad began to carry great cargoes, but you'd had to have the great canals. You had to float things. The ocean, you can have incredibly large ships. Once you load your cargo, you can get it thousands of miles. And ships could carry loads that human beings couldn't carry on their backs, and couldn't carry on the backs of animals. As Sir Halford Mackinder showed in the English long ago, that when the railroad came along, they started the marine railway. The first railway was a marine railway, built a ship to lay down in the sea using gravity to accelerate it in. And you had, then with the marine railway, the ship could tip over. But they then doubled the idea so that your ship won't tip over, and this became the railroad. And they ran the tracks back up on the land. They developed the steam engine for the ship, and so they put it on the donkey engine on the thing and run it back up on the land. So so Halford Mackinder showed the English the railroads were the ship technology coming up on the land. This advanced engineering really coming up on the land. And it warned the English that the coastline was not where they thought it was because of the ability to carry great cargoes suddenly up on the land. But the World War II tanks and so forth, what was called the Blitzkrieg, was the water technology coming up on the land, because on the land you had siege, and the trench war, you just stay in, siege. But what happened long ago with the human beings developing city-states, and the successful city-states being such as Mycenae, sometimes they became so successful that they had a chance to also get into producing boats. And probably the fall of Troy is the beginning of the city-state masters building ships. And the Greeks had these ships, and they then were able then to come up to the castle. Up to this time, the people outside the walls simply starved. But suddenly the invaders came along with ships, and the ships could keep going off. The people inside of Troy just had so much food, they thought it was going to be great, that the people outside just going to starve. But the people who came along were not starving. They had ships bringing incredible cargoes. So that suddenly the line of supply began to be the new grand strategy of who was going to survive on our planet. And we find then the time of, you look in Italy, all those great castellos commanding these different valleys, and they're great overlords, giving themselves that name they want to. And suddenly the man who's been developing ships, coming into, he's able to carry enormous cannon and so forth. He comes into harbor in Italy. There's a great castello there, and he just lets it have a couple of shots, and he said, I don't want you to know any more about my grand strategy, because at sea, 3/4 of the earth being covered with water, the people who then built ships and built them to carry great cargoes from great distances with enormous, extraordinary risk to do it, did not tell the other man where they were going when they would be back, or what they're going to have on board. Because the ocean is so big that the curvature of the earth, as to say, it man's down under the horizon, 14 miles away from the sailing ship. And so that the sea kept her secrets. The people then who went to sea and were going to produce enormous wealth by synergetics of getting resources that exist over here that don't exist at home, but other resources exist at home that seem to have no usefulness. But you bring these two together, and suddenly they produce something of enormous advantage, and great wealth has been generated. So that just when I was young, even the expression still was very, very prevalent, because I actually grew up with it, well, just the tail end of the clipper ship times. And they say, if you just wait till my ship comes in, one ship in, and it's a fortune. So it was an enormous big risk to build that thing, but if you could endure that thing, it will work. But you didn't want, no time at all, when you go to sea, to find the people who were able to build the very best ships had to be very powerful overlords on the land, because they had to be able to say, I'm going to build a ship. And had to be able to say, I want all you people who produce, all you woodworkers come down and build my ship. I want all you metalworkers come and work in my ship. I want all you people who have been sewing, making clothing, to make sails in my ship. They had to command the whole economy, and they had to say, all you people now grow food for my people working on my ship. That'd be very powerful overlord. And to consolidate, had to have a very good advisor, a very good designer who's been well appraised of the experience of others before us. So he builds this great risky ship. Then there's another overlord who's not anywhere nearly as powerful, and he's very jealous of him. So he said, I know, very easy, I can just build a smaller ship, and I got to wait outside the harbor until the night before he gets home, we just take him over. And piracy became very, very popular. And simply a question on the water, incidentally, at no time historically could the people on the land anywhere enforce their laws out on the water any further, so that you could throw something. And projectile, so 3-mile limit and so forth. But the law, 3/4 of the earth is outside the law, and the people who then lived in that water ocean world really became world people, were inherently outlaws. And you find the top ones are called sovereigns, and the other ones are just pirates. So the great pirate became sovereign and gained great respect. In fact, they told everybody in the world exactly how you carry on. And they set the standards. We find what came about that changed a lot of this, and is mathematics. I did not talk to you about the Arabic numerals, did I? The Arabic numerals and the Roman numerals. You're familiar with the Roman numerals. Would you ever try to do a multiplication of the Roman numerals? Or division? How do you get on? You don't get on. Yeah, the Roman numerals invented, again, I've talked about power structure. The power structure, man could have anybody, very ignorant slave, say, I want you to stand here, and every time a sheep goes by, make a scratch. It was a scoring system, and had to do with things that kept life going. And this was the wealth. So every time a bag of wheat goes by, you make a scratch. And then there was a supervisor, and he'd come along and make a secondary kind of his kind of check mark. It's not kind of V check mark today. So we have the scoring, and people, the whole Mediterranean world, the Roman Empire, using the scoring system. Not until 700 A.D. does they come into what you and I were taught historically of civilization around that Mediterranean world. 700 A.D. the Arabic numerals begin to come in, but they're employed by people as a shorthand for the Roman numerals. So it was easier to go like that than to make 3 marks. And they were just thought of that way. The Arabic numerals, however, they had the cipher in it. And in the scoring system, you can't eat no sheep, so you didn't need a symbol for no sheep. You just wouldn't know exactly how many no sheep there were, how many symbols you needed it. So the cipher had absolutely no meaning to the people who used Roman numerals, because it was a scoring system. So they thought that the cipher of the Arabic numerals was some sort of a decoration, so it's a period that you put at the end of your work, whatever it is. And so the Arabic numerals then came into the Roman world, the total Mediterranean world, in 700 A.D. It was not until 500 years later, 1200 A.D., that a treatise is written by a Latin in North Africa explaining the cipher, the function of the cipher. Now, my own speculative going back into things of the archaeology of the sea, which I've been so interested in, and the evolution of design of ships at various places due to the kind of woods they had and the kind of waters they had to fish or whatever it might be. I'm not forgetting my Arabic numerals and so forth, but just I had mentioned earlier an archaeology of the sea, where I was very fundamentally aware as a sailor that they were building ships in the Sea of Arabia exactly as they described being built in the Bible. When human beings did go out in the water and were safely back, they began to like that particular ship very, very much. And you couldn't get those people who were building the ships and sailing them to change once they found a fairly successful one. So I found that the boats all around the world, they were quite different. You went around one cape into another. Fishing conditions were different, the seas were different, the different woods to work with. And so that it was fascinating to me the different types that were around the world, but they'd been holding steady for thousands of years. And I could see the interrelationship, and you could see which one came before the other. So I saw there really was a visible evolution, and archaeology, and the sea was still operating over the thousands of years, and the land one, it over long ago, and just burying it. I'm uncovering it and trying to put some shards together, but this is something you could really get tremendous information. The fact that you could carry those cargoes enormous distances, and that people are still using ships in exactly the same way they had been. One will go to India today and still see the numbers is extraordinary. Boats of yesterday have been running the monsoon seas for thousands. Those captains say they've been sailing between Africa and India for 10,000 years. That's their own reckoning. But the very little evolutionary change, and you learn exactly which ship could come before the other and why the kind of winds or whatever the condition did what they did. So I became tremendously interested in being able to explain history from the water side, in contradistinction to trying to piece it together archaeologically on the land side. Though there are relatively few people there, it had to make sense. It was an engineering kind of logic that would be much more revealing, I felt, than the kind of things that people could with their superstitions and so forth on the land, they could kid themselves into even though this was starkly the way it was, it didn't necessarily have to be very logical. I come back to the abacus. I'm quite confident I spoke to you about the probability of life really beginning on those South Sea islands, and what I'm saying to you now is tending to prove to be correct. My theory of a half century ago is getting to be very, very highly substantiated. During World War I, beginning outside of World War I, the Germans controlled the Caroline Islands in the Pacific, and on one of the Caroline Islands, the most eastward of it, the German commander suddenly found himself the English ships had come in and taking him over. He wanted to get word quickly, because the World War I had not been announced. He wanted to get word to his commander, who was on an island 1,000 miles to the westward. There was a legend on the islands that the people, the sailors with their outrigger canoes, very fast sailing proas, that they were able to go offshore, off the soundings. They could somehow or other able to navigate, and so he gave a message to the leading navigator's boatman there and asked him if he could get this message to his commander 1,000 miles to the westward. The answer came back in a few weeks. He had done so. This is the first time the Europeans ever knew that the Pacific island sailors did know how to sail off soundings and to work on celestial navigation of some kind. There was an enormous European conceit that went along with the Magellans and the Drakes and so forth, going around the world seeming to be very superior to their ships, and thinking about those people, naked people in the Pacific that don't know anything, just very ignorant people naked. Since World War II, when the United States had had a very large mandate to deal with in the Pacific, the Navy's had to do a great deal of work, and it is now generally conceded by the students of maritime science that navigation clearly began in the South Seas, in the Pacific. There are various things that I can tell you about this that are to me very fascinating, because I became a student of this subject. When I take the large map of the world, and we can go, let's look at my map over here. This Pacific, the great Pacific Basin, all this enormous area in here, getting down to our South Seas are in here. And this enormous Pacific Basin, there's something very important. The language is all the same language for this enormous area. There are alliterations and dialects that come from it, but it's all one language. There is a professor who was at my Southern Illinois University in Southern Illinois, and then he went out to the East-West Institute in Hawaii, and he was a great expert on that language, and he also then put the problem into the computer. You can tell, if you're an expert in languages, what is an alliteration, what is the prominent way of saying this, and then the ignorant way of saying it, how things change. Taking all the pronunciations on the Pacific and using vectors, it found that all the languages of the Pacific, which are all the same, all went back to the island of New Britain, just east of New Guinea, right here. Now, you get into New Guinea, and you get over a mountain, and there's another valley, and there's people. Valley after valley, and there are hundreds and hundreds of tribes, all speaking completely different languages, nothing to do with each other. The minute you get on the land and the difficulty you get from here to there, you get really, really separate languages. But these water people, all the same language. Due to the fact you go incredible distances on the sea. In the history of the Maori, who had been to Hawaii, and historically it's known that they made several trips from your friend Jim Mitchell wrote the beautiful book of Hawaii. They've made several times they've been up in the Pacific and then gone back to New Zealand, where the headquarters are now. Those have been hundreds of years apart before they've gone back to, for the moment, some kind of headquarters. In the language of the water people of the Pacific, Maori, they were thought by the Europeans to be extraordinarily ignorant because they said they could only count up to 2. They were using the binary system long, long ago. As we get in the computer world, we suddenly realized this is the way to carry on, so that you have to revise your appraisal of people on the basis of this. They couldn't do any better. Also, all these water people were considered to be very low order of man because in the first place they didn't have any literature. Anybody had any culture would have a literature. Now the fact is that if you live on the sea, you can't have any library out on a raft. The ocean's going to go over you, and that's not the way you're going to handle your information in printed or on paper, so forth. The Maori have kept their history entirely by memory, and they teach the children their history. And when you come to the land places where the Maori will exist from time to time, they have these long houses, and they have columns of the house, and the ribs of the roof, which are originally the ribs of the ship. And each of these columns is an ancestor, and they sing their chants about their ancestors. They're able to go back about 100 ancestors, and I doubt if you can go back 4 or 5. They rarely memorize it, and their words and their chants say things they don't even know what they mean, but from father to son, they learn to say it that way. So if you do get any kind of key, you can really open it up. But it's been then carried on verbally, rather than being on printed paper and so forth. These water people then, being naked, don't have any pockets, and you're going to have some important information. I'm getting these what they call the long ears, where they split the ears, and ears can open like that, and then here, these big discs. Those have turned out to be actually cardinal points of the compass. this was a very extraordinary piece. Nothing could get off your neck and their arms. So these various rings and things that they're wearing are ways in which you do calculations and things. These are the only pockets you have if you're naked on the sea. Not going to lose. Very important information. So things have been looked down as strange, so strange to the European. That, so this is wild people are very, very mature and very economic, very efficient kind of information controlling devices. Now, one of the most interesting things you get into mathematics and the number of the language of science, beautiful book by, I don't say his name quickly, it will come in a little bit. In the number of the language of science, one of the classics, there is a listing of the names for numbers in different languages, all the different tongues of our earth. In the world of etymology, the world of the science of words, there are some words that are called old words that transcend any ability to trace where they came from, what they're all about. Amongst the old words, there are very few of them, all the names for the numbers are old words. They don't know where they came from, except for one word. For the name for 5 is very often identified with the roots for the hand. But all the other numbers are absolutely, there's no physical experience that anywhere connected with the word. They're apparently really abstractions, they're words for abstractions. At any rate, if you see the names for these numbers in different languages all around the world, Tobias Danzig is the author of a number of the language of science. If you look at his list and these names, and I'm going to say to you, one of these two words means 1 and the other means 2 in these different languages. I want you to tell me which one means 1 and 2. You'll never have any trouble. You suddenly find that it really actually is a quite great similarity of these, and it goes running through them. The names for the numbers have very important similarities, and the difference between one, the vowel sound, and two, a very vowelish one and a very consonant one. And this holds true all through them. And so that one of the things you have to say, which is really very surprising, in view of something I gave you about this language covering the whole Pacific, and the names for the numbers all around the world having extraordinary interrelationship, either been some kind of angels that flew around the world dropping leaflets on the names for numbers, or they somehow rather got around. The only way they can get around is by water, and the water go everywhere. So it looks as though the water people have been getting around the world for a very, very long time before we have any record of it. And the more you know about the water, the more you realize the wealth that it really could command, you realize how secret it is kept. Is my own working assumption right now that man has been known about this, what I call the great merry-go-round, where the waters and the airs go like that around here, take you into the Atlantic, into the Indian, into the Pacific. That this merry-go-round, where 90% of humanity out here in the ends of the propeller, and this is unknown except to very few people. This gets you anywhere that you command the world. This is the command of the world, and people are not there to know about it. It was the key. It's the integration of the earth. And I told you, Admiral Hand startled the United States Navy by pointing out that English discovered long ago there's only one ocean, and the center of that ocean is here. At that time, we hadn't gotten to the South Pole, knew very little about this. Captain Cook went around and he saw ice, but he didn't know the continent was there. That's the time when Hawaii gets rediscovered. So this is I want you to notice then, here's New Zealand, where the Maoris come to. I've gone to see quite a little of them, and I've been down there in New Zealand 3 times, and the head of they have an anthropologist who's in the University of Auckland is a Maori, and he is what they call the keeper of the chants. And I said, I wish he would. The tape recorders have just come, and they've never had tape recorders before. And I thought it'd be a good idea if the chants were recorded instead of having to be memorized where they are. And he said, no, that would be very much against their principle to have it done. They could only chant. You could only do the chants for other Maori, and they said, you're not a Maori. And so I got up a little joke. So well, I said that I really was a Maori, but I hadn't been back home for a couple of 100,000 years. And in New Zealand, one of the very interesting things is an island way down here, do you see, almost to the Antarctic. And there they have a very extraordinary mother of pearl. And the Maori have been taught to go down there, get that mother of pearl, and in all their houses where they have their ancestors, these wooden statues which are ancestors, the eyes of the ancestors must be this particular mother of pearl. So I explained to the Maori that the reason that these were the eyes of their ancestors down here was that the ancestors knew about the merry-go-round of the water. The Maori themselves hadn't really realized this, but by this time they've lost track of that fact. But if you were here, you had a ship, if you could stay afloat on a raft or not, you could get around in all these places. And so I said, a couple of 1,000 years ago, I got stuck in the Atlantic for all these years, and I was just back. So would he let me make tape recording, but he wouldn't let me do it. Now, I'm introducing to you what I'm quite convinced about now, which is that the life really began. The life began out here on this water, and it comes into the land. I give you about that and how we have the tribes going and about the colors and so forth. But the anthropologists and the archaeologists have been assuming life began here somewhere, kind of Garden Eden here, and was gradually somebody went west, went east to India, to China and so forth, and then from China down into India, they said. And all the assumption has been always that the arts and everything came from China south into Southeast Asia was very last. If you go to your in the University of Pennsylvania here, the Museum of the Science of the Museum of Pennsylvania has the task of doing archaeological work on the great diggings here in northeast Thailand. In northeast Thailand we have a place called Ban Chang. If you look at your National Geographic magazine of Christmas time 3 years ago, the cover story is of this Ban Chang discovery. There they have found a culture, and many of the things in it, the quality of the culture, like discovering the Etruscans, incredibly beautiful design. Here we have culture going back, what do we have in Egypt, 8,000, back 15,000 years. This is by far the earliest known. It's now completely conceded that this is where the Bronze Age began. This is where these water people came in here. In other words, I'm quite, there's more and more realization now of the theory that the life really has come this way, rather than the working assumption of the Europeans that really, the land people, that they were so smart and so forth. I think in your day you'll learn more and more that this will be confirmed and confirmed and confirmed, whether it's the very old people you find on the east coast of Africa, because there's traffic there, kind of the monsoon seas, you go right across that Indian Ocean back and forth, it's all involved in it. And I've been to a great deal of Africa, and in South Africa, and the Southeast Africa coast, I really feel very powerfully what I'm telling you about. The Mombasa, there was a professor at the head of the architectural department at Cape Town, Thornton White, when I was invited to go there in 1958. He was an architect who had been trained at, and he went to Oxford, and then he went to Harvard, a cultural man. And Thornton White told me that after just the end of World War II, the English were spending a great deal of money, as yet, guarding the east coast of Africa here against smuggling. There are enormous smugglings going on in the Indian Ocean. The British had decided at the time of World War II that the British Empire was all over. I think historically the people of England will get very great credit for, as far as I know, it's the first really top sovereignty that's ever really deliberately taken itself apart. They assumed that they really were through. I talked to some of the leading statesmen. They were coming into World War II, and they said this was going to happen, and they really deliberately pulled back and pulled back and pulled back. They've not really been pushed out. They did absolutely voluntarily. So basically, this chapter of history is all over. Anyway, they were wondering whether to keep on looking out for this smuggling. So they had the Navy ships were used for to prevent the smuggling. And Thornton White, my architecture friend, had been born in the island of Mauritius, here in the Indian Ocean. Here it is. And he had done a architectural town planning for the island of Mauritius. Because of his familiarity with this Indian Ocean area, he was designated by the English government to look into the matter of whether it would be wise for the English to keep on trying to stop smuggling, to protect the businesses they had here, or not. And so he, in the monsoon seas, the ships that cross the Indian Ocean come down here, and at Mombasa they beach them out and clean their bottoms and so forth, get ready to go back this way. It's an annual thing going with the winds, and so the big fleet of the Indian Ocean dhows comes in there. So Thornton White went to there at the time when they would all be in highest concentration. When he got there, he said that he was taken to meet 3 or 4 of the top dhow captains. So now one really seemed to be there. They seemed to have an admiral. He was the admiral of their fleet. Thornton White, I want you to remember that he had been to Oxford and he'd been to Harvard, and he had experienced what we call culture anyway. Thornton White said to me that these dhow captains that he met, the leading ones, were the most cultured human beings he'd ever met anywhere around the world. There's nothing comparing them. And he was astonished at their knowledge. They said to him, there was a curve in human affairs, these curves of acceleration, and it gets finally to a peak. And then when there's a fall off, there's a shoulder form, there's really a very constant curve that nature has shown here. When something stops, it doesn't stop right away, and there's a fall off. They said, to their own satisfaction, they had actually been trading across the Indian Ocean, their forebears, that their law and their knowledge of the sea, one captured another, that they've been doing this for 10,000 years. Here's a curve of 10,000 years, and if the English could stop us, the deceleration curve will take 300 years. So we might as well tell them that. He said, incidentally, when he arrived there, they knew he was coming. They knew all about the underground, had that very clear, and they put on an expedition for him, and they showed him. So he went back to all the English, might as well give it up. So they did give up that East Coast work. But this was in my greatest interest to me that he thought it was deeply convinced that they had really good reason to believe that they've been navigating for at least 10,000 years. And when we get to find there's an extraordinary culture 15,000 years ago, would be right on that route. It's be very interesting. In my total subject that I'm dealing in here with you, I gave the name Naga quite a long time ago because in the there are the Nagas in right here in India. In this area where people first came up on the land, Naga is the name. It means the sea serpent. And to the water people, if you look to the horizon at any time at sea, you see that back, the snake's back, the great sea serpent's back out there. And if you come up in a mountain and look down at where the sea comes into the land, it's obviously that way. We would call it a river, but it's quite clearly when you can see the shape of the water. He was a serpent, sea serpent. And incidentally, the art form of the Maoris is absolutely fascinating. To them, water is normal. An island is a hole in the ocean. They look on a harbor is the penis of the ocean going into that land. The sea is a positive, and the water is the land is a negative. I want you to really feel that the sea is normal. It's in this great motion. It's a very different kind of a tradition, and it's mighty. And yet it has extraordinary things. We find now the navigation they were doing. They were sailing for the rising of this star, the setting of that star. I did mention these navigational tools that Thor Heyerdahl talks a lot about in his Easter Island, where they found these strange sticks crossings over. They thought some kind of decoration over there. All navigational tools. Now, all that's all thoroughly confirmed today. The Naga is, and then in Japan, the name for the river is Nagala, or really female Naga. There's a great deal that goes into what the kind of things I talked to you about of my Naga business. In Japan, the name of for the roof, the ceiling of the house is the word is the name for the bottom of the boat. I'm quite certain that the first people began to get into, in contradistinction to dugouts and outriggers and grass boats, getting into ribs, where the stiff ribs made possible really very large bellied boats. And those ribs then, the rib boat people, I was lucky to be in Cairo at a time when that sunboat was found about 20 years ago, and they let me in to see it. That same year I visited Norway and saw Oslo and saw the boat that they had found in deep in the mud, the Viking boat. The Viking boat and the Egyptian sun god boat were the same boats. They were plankings that had been lashed together. They had their ribs and they had the thwarts. The thwarting and the ribbing, everything they were so absolutely the same boat. I was astonished by it. I'm quite certain then that while people learned to sail into the wind, as I gave you yesterday, the minute you can tack and you find that you can really work to windward, and people did work to the westward, in great contradistinction to the people who probably for in untold thousands of years did drift on rafts. So it's pretty easy to design a raft, just take a number of the logs falling in the sea and tie them together. The people did get around in rafts, so they had to drift where the currents took them, where the wind took them. But the people who began to develop the sailing boat and the prevailing currents of the world are from west to east. So I think that this is what Thor Heyerdahl showed up in his Kon-Tiki, was that the rafts could follow those great currents of the Pacific. So I think that the early raft people who went from the South Seas, get up on the land, but also then go over to the Americas, both the west coast of North America and the west coast of South America. But now I have water people who are starting westward instead of going eastward. A very different kind of the world. And you could, with no wind blowing, you could row. And it's really interesting that and you can paddle. But the paddling dugouts were very poor. The very best of them you see in Thailand today. The King's great barges were several hundred paddling sailors on board. The Vikings had rowing. I think then people rowed to the westward. And I think the Vikings are the water people completely out of this area, because on the Viking boat in Norway, there is a Naga head, a most extraordinary kind of a sea serpent head, and it's very complexly designed, and its exact counterpart has been found in the island of Borneo. I think long before you could sail to the Windward, then you rowed to the Windward. So the prevailing winds coming from the west, so the rowed boats got there a little earlier. And we get then the Viking boats getting to cold country, and they're suddenly going to have to, as a winter, they want to winter out. And you take your boats out and you put them upside down, you can live on them. You immediately have a land shelter, because they're designed for enormous seas, so they can stand the rains, no trouble at all, in the snow. Then I see them taking these boats and putting them, not only one, but bringing them together as a cross form, adds in. And we have then, this is a church form, we're going to call the nave of the boat, the nave. This is an upside down boat. Absolutely counted all the ribbed buildings, the ribbed roofs that came entirely out, turning boats upside down originally. Because you would not get that kind of engineering except by virtue of the sea. Now, these things get to be quite exciting as I go on, and I found then the water people did everything in the terms of the verbal carrying on. So we find the Norse, what they have, the saga. We know the Japanese are absolutely certain that they came from the South Sea somewhere. And their tales, and also you find this in Bali, the same word, raga. These are the tales of the old people, the chants. Whether it's the naga, the raga, the saga, these are all how do you keep your history? By word of mouth. I'm just giving you a little bit of my feelings about the Naga story, but I'll tell you one part of it that I find excites a great many of the scientists. We have the Garden of Eden story. And this is in the Garden of Eden, somewhere in Mesopotamia, Babylonian area, somewhere in there. And what I think went on all the time, because this has been able to be well established in the South Seas even today, the chieftain of an island, a chieftain is a strong man, so I gave you the big guy. And every once in a while, his people begin to not think he's very good, and he needs to establish his credit. The chieftain has always been able to go to the navigator. The navigator on those islands lives absolutely separately from other people. They may teach their son, but they may teach somebody else's son, but they have an absolute tradition, and the chieftain sees they're kept absolutely separate from the people. So the chieftain says to the navigator, I need a miracle. The chieftain doesn't know anything about this boat, but the navigator knows how then go into his swift sailing proa going offshore. He knows how to get to an island when nobody's been to before, and he knows that on that island they have one of these things and so forth that nobody's ever familiar at home. So all he has to do is bring back something to his island and give it to the chieftain. The chieftain holds this thing up, and everybody realizes he's an absolute miracle man again. He's been ordained by some great mystical power. So the navigator was always able to get the chieftain some way of re-establishing himself, so that there's no question. We know all through that all the navigators were always kept separate. Those navigators then finally, when they're crossing the Indian Ocean to the west, landing Mesopotamia and eastern Africa, they began to go up on the land. They began to be both priests and astronomers, and they, using their astronomical things, did a great deal of the pyramiding, so forth, to keep track of these astronomical data. And they were able then to tell the pharaoh, the top man, what to do. And time again, they give him, but they kept the secrets themselves. This is all going to bring me back then, finally, to mathematics and the Arabic numerals and so forth. You've been quite a little while on this session, but I'm going to wind it up with the following. You remember your Garden of Eden story very well, I'm sure. I now will point out that the priests, when people began to catch on to something, promoted some kind of story. And the better the story, the more easily they then were able to hide the secret. We had then this Garden of Eden story. This is when the human beings had then started going to westward instead of going with us. In the Orient, earlier going with the rafts. If you went off in a raft, you say goodbye to people and you never saw anybody again. So there was really a continual dying while he's still alive. Once you understand this, and you went. God blew you this way, and the tide went with it. You were always going along with God. But when you started sailing to wind it, you seem to be defying God. So these people who work to the western then have to have really a new rationalization of their going to against God's wind. So they really have then a God who lets them in on some information, all right, but that you're going to get into trouble if you use it. This Garden of Eden story. I'm going to come back to it. I want you, first we have then Adam, take a rib out of Adam and produce an Eve. That's not a very credible story. There's a way to produce him, and take a rib from a man. The man was there, then the woman came out of him. Anyway, the people who did go to sea and learned gradually that the best of sea creatures are whales. The seals almost had ribs. So the rib cage became very, very impressive to that sailor. And he finally then tried it out in his own boat, which had been, up to that time, reeds that were folded up and did not have any stiffness. So as far as I'm concerned, the rib of the Eve part has also been absolutely fundamental through the ages. The ship is always a female. This place, the ship has an inside, this is sort of a womb and so forth. You can understand why, but she's female. Ships have always been female. So I'm confident that Eve was the ship. And she was made possible by the ribs, the rib cage. And the ship took Eve, Naga, the sea, the serpent. Naga the serpent showed her the ship that you could go around the world. The world is a sphere. That's all the apple is. This is a. Now we find that the great priests had in the pharaoh's crown, so they would have the orb, and they have the two serpents going around the two ways. You go either way and get there. This is very fundamental to the sailor. I was asked to be at the opening ceremony of the Maritime Museum in Haifa a few years ago, and I was asked to speak at it, and they've been doing an enormous amount of discovery of things, because this is the greatest museum of the Phoenicians, and they've been getting so much diving, so well, great have been brought up, and one of the most prominent of the coins is a sailor's coin. Is the Janus is a god of the sailor, but it's two-faced, and everybody said this was because sailors, you know, are very unreliable people. But it isn't so. This is because the sailor knew you could go either direction and come back right up. Go this way or that way, and always come back where you were. You'll find this very deep in the symbolism of the navigator, sailor, priest. So, what I've just given you of the Garden of Eden story, Eve was a ship, and she was made possible by the rib of Adam's experience, that he had a rib cage, and so the ship had the rib, and Naga, the serpent, took around and showed her the earth was an apple, was a sphere. And so that time on, the king always had an orb to hold, and he didn't know why the priest had him hold an orb. That's enough for this time. We'll stop for a little while. You've been very, very patient. The word Naga is a very basic word. The Na of Naga is the Na of Navi, navy, Na of native. It is the nativity. Na, and we have navigate, naviga, Naga. And the V is the way of the sea. It's a very powerful, fundamental kind of a root. In the area from Japan to Burma, this area is Burma back here. Japan to Burma. These people use something very extraordinary, the three-way weaving. This ball is from that middle of that area. And this is, you can see the triangle, what they call the three-way weaving. They make their baskets three-way. All around the rest of the world, is all the baskets and all weaving is two-way. It's 90 degrees. Really pretty interesting that these water people use a three-way. And so their fish baskets, even enormous things, they put a whole animal in there, terribly strong, made out of bamboo, and the three-way weaving. The two-way is very unstable. The three-way completely stabilizes. You can see how it catches up to itself here. I gave you the two triangles the other day. This one, you can see this triangle here and the triangle here, and you go just as far as you can it gets to the center of the triangle. You can't go any further. This one here goes to the center of this triangle. So this is a limit of possible travel between the centers of the triangles. Now, that three-way weave area is also then, as far as I'm concerned, the water people, the world people, and I'm quite confident we're going to learn more and more about this Naga. In the same South African, Southeast African experience that I had, down in the South Africa we have the color reds, people we don't really know where they come from. I learned in South Africa something that really fascinated me. I don't know whether you were, in Egypt we have Queen Hatshepsut. She was really one of the great rulers of Egypt. And she, it's recorded that she sent her she sent her people to the land of Pun to get the pitches and things for her ships. The land of Pun is this area in here, Somaliland and so forth. That's the land of Pun. I learned from Rogers talks about this land of Pun and the Egyptians. Anyway, I learned from the South Africans that the word Pun is the word red, R-E-D, the color red. And this land of Pun, we get that to the Red Sea and so forth. It's a Pun Sea. The Pun is a very interesting word because it also then relates to something somebody spoke to me about here, the pundit. It is the thinker, the person who will be able to calculate. And we have the Pun of the Phoenicians. The Phoenicians, later on the Phoenicians, the Phoenicians were these red people. It seems like the color red might be that. The Phoenician, later on Phoenician. The Phoenician and Phoenician seem to be the same water people. I think the Venetian, the Punic Wars, the wars of the Phoenicians and the North Africa, Latin Wars. So the Pun, that also you get in the Pun of a boat. We call a punt. So the Pun is both boat and it is the wisdom, and it is really was a key to me about the concept of the Phoenicians and so forth. Red. Now, I'm in such a speculative world with you here that I'm going to cut pretty quickly here, but I'd like to go a little more into the tracery of the mathematics which comes out of the Indian Ocean, out of the abacus, the ability to calculate, again, sliding rings, very much as these water people have rings on their arms, and they slide rings on beads on bamboo rods. The navigators coming up on the east coast of Africa and coming into Mesopotamia, the Babylon, and we have the very interesting interconnection now of the island of Crete and the island and Mycenae on the land, but the water people and the Mycenaeans and the Cretans apparently very closely interrelated. We established a complete relationship now between Babylon and Crete. Crete was very particularly of importance in that Aegean world and the Eastern Mediterranean world, and it was completely unfortified because these are the water people who were now really absolutely controlling the waters. Therefore they didn't need any fortification. Nobody could get to their island. And I've become particularly interested in Crete. I've been there quite a number of times. And in the great palace of Knossos, which then the Cretan civilization breaking down in about 1400, the palace of Knossos, in the king's quarters, there is the king's symbol. The archaeologists call it the double axe, but it is simply the hexagon, strictly the hexagon. And if you can draw the hexagon with two sides like this, one of the two opposites, and they call these double acts. I don't know why, but anyway, clearly it is the hexagon with the 6 radii and the 6 chords. And in the woman's side of the household side, they have the distaff. And this distaff sign, you find them in the walls a great deal. And the distaff side is a square with a cross. It's like the English flag with the two crosses, the diagonal cross and the perpendicular cross. And that's the distaff side. So there's this 60-degree angle in the king's side, and there is the 45-90 in the distaff side. In history, I find it fascinating matter that going back to the history of science and history of scientific and technical artifacts, we have irrigation in India, so forth, and there is absolutely suddenly, out of a complete void historically of science, we suddenly have quadratic equations in Ionian Greek. And this seems to me to be a very abrupt matter, and everybody tends to think of those Greek geometers and the Greeks as the beginnings of mathematics. But beginnings are really a very high level with quadratic equations. Llewellyn Thompson is the anthropologist at the archaeologist at the Institute of Advanced Study in Princeton. He's also head of the archaeological teams, American teams in Athens, and he restored the Stillwell, and I got to know him. And I said the following to him: as you go into synergetic geometry with me, you're going to get more and more into that triangle, which I've already introduced you to, in the tetrahedron, and the fundamentality of the triangle. And here's this hexagon in the king's side, and the king, this is a world of navigators, where the king is the king because they rule the seas, as water people. And we find that their mathematics and advantage was tied up completely with Babylon coming from the Indian Ocean. So I became fascinated with the idea that because the navigator had been able to keep his secrets so completely up to this time, that the falling of the great palace of Gnosis occurs when the really master water ocean people are broken into by the lesser water people of the Aegean, and they are suddenly, their mathematical tricks are taken over, and the Ionian Greeks represent then for the first time, mathematics coming out into the public domain. Mathematics has been there for a very long time. And this explains then this very suddenness of its appearing in the history. It had been kept absolute secret up to that time. Thompson thought this was a very reasonable working assumption. But what fascinated me most was that the king had kept, he was working in the 60-degrees, and he had the people working in the 90-degrees. I've already made clear to you really this difference between the squaring and this inefficiency and the enormous efficiency of using the triangle. But apparently, this seems to be, and I go back then into a Solomon's seal, or whatever it may be. We'll get into the triangles of the seal of highest wisdom and so forth. But the triangle is known back there, but it's known to leading very powerful people, but it's not out in the public domain the way to calculate. Now, I'm not being deliberately slow. I'm changing my subject to something. I really opened up today and historically talking about this Greek period and the Mycenaeans, the going to Troy and the siege of Troy, and I spoke about then a grand strategy of land people for a very long time, while man did not know much about boats, land strategy, just the big and heavy and high, the fortress, the city-state being a very successful form of invention for the people, powerful people to be able to keep themselves very powerful with it. I have all the things inside the walls and people outside starving. But Troy seems to me, and Homer, to be then the beginnings of a realization that the water begins to bring a line of supply, and you can then have besieged these great castles. I point out to you then that in Italy, the time, early time, Venice, nothing can be more impressive than Venice, because Venice, all the rest of Italy, great castella walls, and Venice absolutely no walls whatsoever. And these were then the great water people, and the water people were gradually taking over on the land people. And so that Venice didn't need any fortification because it controlled the seas. We find then the rest of Italy very, very hostile to Venice, because they were able then to break the great security of the Castello. They're moving their ships around, bringing in. Now we have, up to this time of Venice, and the more I can see of history, the Orient then is the beginnings, and the Southeast Orient is the very earliest beginnings, and the knowledge that is required and the culture is very, very great, and nothing is more extraordinarily impressive than the ancient Chinese history of what humanity really had learned, where we have quaternary alloys of metals, back in 400 BC. And so now we know that metals game began in the Southeast Asia, going back thousands of years. So that there was, in the game of the people who were able to sail to the windward, they would come back to the Lord, and they were able to go back home and get great riches, and found that the people opening up the frontiers were very strong people, but had great needs, and they were able then to continually cash into the westward. So the European world opening up and around the Mediterranean brought about then a market for goods from the Orient. And there were 4 main routes from the Orient. You could come north, the Lake Baikal, the Sea of Azov and Caspian, the Black Sea, and through the Bosphorus and what is today the old Alexandria, whatever. But the point was you were coming into the north of the Aegean, and this was the Orient. And from there on, you could get on waterborne and get to various parts and goods could get gradually up into Europe, opening up of Europe. We have of Northern Europe, and then there was another route coming over Sinkiang and the Khyber Pass through Persia and to either across Mesopotamia to the Asia Minor coast there, or it could come down in the Sea of Arabia. Then there was the traffic coming via the